Greetings, Calc 2 students. This video is for section 1110, and it's example number 63 from our homework in our book. So, an application of the power series that we might run into is this style of question, where we're asked to use this series to evaluate the limit. So here's my solution. The sine of x as a power series is equal to the sum as n equals 0 to infinity of minus 1 to the n times x raised to the 2n plus 1 over 2n plus 1, the whole thing factorial. And if I write out the first three terms of that, I'll get x minus x cubed divided by 3 factorial plus x to the 5th divided by 5 factorial minus x to the 7th divided by 7 factorial, and that will continue on. So I'm going to substitute this sine of x for this Maclaurin series expansion of sine. So when I do that, I got the limit as x approaches 0 of x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial plus dot dot dot. That's the same as sine. Then I have minus x. Then I have 1/6 times x cubed. So plus 1/6 times x cubed. And then the whole thing divided by x to the 5th. So this is equal to the limit as x approaches 0. And if we notice, this x and this minus x will become 0 when I add them together. And this minus x cubed divided by 3 factorial is the same as positive x cubed divided by 6. So these, when I add them together, will become 0. And that will leave me then with a limit as x approaches infinity, x to the 5th over 5 factorial minus x to the 7th over 7 factorial plus dot dot dot. And all of that is being divided by x to the 5th. So I have x to the 5th over 5 factorial divided by x to the 5th. So that's just going to be 1 over 5 factorial. 1 over 5 factorial. And then minus x to the 7th divided by 7 factorial over x to the 5th. So that's going to simplify to minus x squared divided by 7 factorial. Then the next one would be x to the 4th over 9 factorial. And then minus, and that would keep on going. So how did I get that next one? Well, let's see. That would be x to the 9th over 9 factorial. And I'm dividing that by x to the 5th. So that would simplify to x to the 4th over 9 factorial. And that pattern would continue to go. Then as I apply the limit, the first term would just be equal to 1 over 5 factorial, and then the rest of the terms would be 0, right? So I'd have minus 0 plus 0, minus 0 plus 0, and so on, because each of the rest of the terms is going to have an x in the numerator and a constant in the denominator. And so that leaves me with 1 over 5 factorial, and which is 1 over 120.